Hello and welcome to another absolutely free and wonderful science lesson from freesciencestuff.com. Well, today we're going to spend some time talking about how to use a triple beam balance correctly to measure mass. And let me just first of all say this. This is in fact a balance. It's not a scale. And it does measure mass. It's not really measuring weight. And just to give you an idea of how this works, let me just say that this balance would actually work the same on the moon as it would on the earth. It does not depend on the weight of the objects. It doesn't depend on the attraction due to gravity. In order for this to give you a correct answer, it doesn't have to have an acceleration due to gravity of 9.8 meters per second squared like you have on the earth. It could be the acceleration due to gravity on the moon, 1.66 meters per second squared. Whatever the acceleration due to gravity, as long as there is some gravity to pull down equally on both sides of this balance, then this will give you accurate, precise measurements, at least precise to, in this case, 1/10 of a gram. So with that said, let's talk about how this actually works. Well, like I said, when you place something on the balance pan, what you're doing is you're comparing the amount of matter here with the amount of matter that you have on this arm. And so therefore you're measuring mass. And what you try to do is you try to have the mass on this balance pan, when it equals the mass on this arm out here, you'll notice that that pointer lines up with the 0 mark on this post. And then the object will be balanced, and when you read it you can tell what the mass is. So let me talk a little bit about how to set this balance up. The first thing that you have to do when you walk over to the balance is you want to make sure that all these riders are set to the far left side, which is going to be on 0 in that direction. And when you look at the riders, you notice that the large rider actually measures in hundreds of grams. Each of these notches that you see here would equal 100 grams. You also have this smaller rider that measures in tens of grams, and then you have this littlest rider down here, and that one measures in single grams down to a precision of 1/10 of a gram plus. And if you watch the video on how to measure with a ruler, you get one estimated position in the hundredths place, and that would be either a 0 or a 5. And we'll talk about that again in just a minute as we go through this video. Well, a couple of cautionary things. These balances are pretty much indestructible, but they're not indestructible. And when you carry them, you always want to keep 2 hands on them. That's, I think, a really good idea, because just to be on the safe side, if you drop one on your foot it would hurt. Not to say it wouldn't break the balance also. But if you look at this, there's a piece of aluminum that rides up and down the slot on this post over here, and that piece of aluminum can very easily be bent, and if it gets bent, this is not going to give you accurate nor precise measurements. So you want to make sure that that piece of aluminum is riding freely in that slot. It actually rides between 2 magnets. The purpose of the magnets is to dampen the swing of that balance. It helps it stop from swinging. How does it do that? Well, the magnets are opposite each other, and the magnetic field between them produces eddy currents in the aluminum, and those eddy currents in turn interfere with that magnetic field and dampen the motion of that arm. So it just helps to stop the arm from swinging like that. Well, when you walk up to the balance, I said that you should put the riders at 0, and then also underneath the balance pan there is a little, and I can show you this, underneath the balance pan there is a little knob. You can just see it peeking out right there, and that little knob right there is used to 0 the balance. I can show you a better view of that. Let me show you a view underneath that balance pan, and you can see that little knob that you would turn to balance that. And there's, with that view that you see right there, that little knob right there it actually says 0 on it, and if you turn it clockwise, it makes the balance pan arm a little bit shorter, and it will help you adjust that 0 mark. Helps you zero the balance. If you turn it the opposite way, it makes the balance pan a little bit longer, which would bring that arm up like that. So shorter clockwise brings it down, longer counterclockwise brings it up like that. So you turn it, and you can adjust that 0 mark right there. You can adjust that and zero the balance, and that's really all there is to it. And from that point on, you're ready to measure the mass of something. So I guess we can just go ahead and measure a couple of masses and get used to doing this. So how do you measure the mass? Well, I'll take my pen right here and I'll put it on that balance pan. And you notice that this arm, the triple beam, moves up. Well, we want to try to get that triple beam right on that 0 mark. And if we can get that triple beam right on that 0 mark, we'll know that it's balanced, and the mass on each side will be the same, or the pull of gravity on each side will be the same, and that will measure mass. So the first thing we do is we start out with this large rider, and we move that large rider out 1 notch, and if the beam falls, we know that the masses of the pin is somewhere between 0 and 100 grams. I'm going to move that back. 100 grams was too much. So I go to the next rider and I move it out notch by notch until the beam falls. So if I move it out there, it falls down. So I know that my mass is between 0 and 10 grams, but 10 grams is too much because it fell down, so I move it back. And so now I go to this little slider down here, and I move that slider out until that beam falls, almost there, and lines the pointer up with that 0 mark. A little bit more, just a touch more. Give it a chance to dampen there, maybe just a touch more. Far. This is the hard part. Okay, that looks pretty much zeroed from where I'm sitting, and if I read this, I can see that I have no hundreds of grams, so nothing goes in the hundreds place. I have no tens of grams. I do have single grams. Actually, I have 9 single grams, and then it looks like 4/10 of a gram. And this little pointer that you see right there, that little pointer looks to be halfway between, or pretty close to halfway between, the 0.4 and 0.5. So I'm going to call that 9.45 grams. Why 9.45? Because I have 9 grams, I have 4/10 of a gram for sure, and then I can estimate that last position. And that last position, that last estimated position, that's where the error is in the measurement. And that position can be either a 0 or a 5, nothing else. I can't have 9.42. I have to have 9.40, 9.45, or I have to go to 9.50. So it looks like it's between the 0.4 and 0.5, so I'm going to say 9.45 grams. That's the mass. Well, let's find the mass of something else now. To do that, I'll set this back at 0. Make sure my balance is zeroed. Yep, it is. And I'm going to put that screwdriver on there, and I'll find the mass of the screwdriver. And again, I start with the large rider and I move it out 1 notch. Does it fall? Yep. So that tells me that the mass of the screwdriver is between 0 and 100 grams. About 100 grams is too much, so I move it back. And then I go to the next largest rider, the 10 gram rider, and I move it out until it falls. Okay, it fell down at 60 grams. So I know that my mass is between 0 and 60 grams, but 60 is too much, so I'm going to move it back to 50 right there. So I know that my mass is between 50 and 60 grams. So I need to add some grams in between 50 and 60, and I can do that with this little rider down here. And I can move that out until it balances. Almost. Almost. Yeah, a little too much. Okay, and that looks almost zeroed. Maybe right there. Okay, that's zeroed. At least from where I'm sitting it is. And if we read that, it looks to be, I'm going to say 51.3 grams. 51.30 grams. And there has to be a digit, an estimated digit in that hundredths place. And that can be a 0 or a 5. In this case, I'm going to say it's a 0 because it looks like this pointer is right on that 0 mark, right on that 1.3 mark, and it is. So I'm going to say 51.30 grams. Basically, that's all there is to using a triple beam balance. It's actually pretty easy. So we'll go on now, and I'll show you some pictures of measurements that I've taken, and you can try to figure out what the masses are. Alright, now we can take a few minutes and practice what we've learned about the triple beam balance, and we're going to look at 8 different problems here and see if we can't figure out what the readings are on these triple beam balances. So the first one, we have, well, obviously here we have no hundreds of grams. We have 40 grams back here, and then right here it looks like that marker falls right on that point, and that is 3.2, and we get one estimated position that has to be a 0 or a 5. So it looks like that line falls right on the mark, so this is going to be 3.20 grams, and we add 40 and 3.20, and we get a total of 43.20 grams, and that is the reading on that balance. Alright, our next reading here, we have, looks like 100 grams there. We have 10 grams here, and down here you notice that this point looks like it falls between the 3.9 and the 4.0. So we're going to call that 3.95 grams. And so the reading on this is 100 plus 10, that's 110, plus 3.95, so it's 113.95 grams. There's our reading, 113.95 grams. That's 100 plus 10 plus 3.95 gives us 113.95 grams. Alright, our next mass reading here. Let's see, it looks like we have no hundreds of grams there. We have no tens of grams, so nothing in the tens place, nothing in the hundreds place. But we do have down here 4 whole grams, and then it looks like a slightly over 5/10 of a gram. That mark right there, looks like it's slightly beyond that 4.5 mark. And so we have an option here. We can call this 4.50 grams, or we can call it 4.55 grams. From where I'm sitting, it looks like it's closest to 4.50, but either one of these answers would be correct, which illustrates a very important fact, and that is that last place right there, that last place, that is where the error is. That 0 and that 5 That's where the error is in this measurement. And that last digit has to be either a 0 or a 5. It can't be anything else. So I'm going to go with 4.50 grams. You might go with 4.55. Both of us are correct. All right, this next problem, it looks like we have 300 grams right here. And then back here we have no tens. And it looks as though this pointer points right at or very close to that 3.1 gram mark. So we're going to call this 3.10 grams. And if we add these two together, we get 303.10 grams. And there's our answer right there. Okay, the next reading. We have 200 grams right here. We have 10 grams back here. And it looks like we have 1, 2, looks like 2.40 grams. 2.40 grams. That looks to fall right on that 2.4 mark. So 2.40 grams plus 200 plus 10. So that's 210 plus 2.40. That's 212.40 grams. There's our answer. Next problem. All right, this next problem, we have 400 grams right here. We have 20 grams back here. And up here it looks to be 5.0 right there. So 5.0 grams. So 5.0, and we have to have a digit in the hundreds place. So if it's 5.0, it's going to be 5.00. So 5.00 grams. If we add this up, 425.00 grams. 425.00 grams. There is our answer. 425.00 grams. All right, problem 7. And it looks here that we have no 100s. We have no 10s. But it does look like we have almost a whole gram down here. It looks like 0.9. And I'm going to say, since it looks like halfway between, I'm going to say 0.95 grams. And you notice here that we have a digit in the hundreds place. That digit has to be, remember, a 0 or a 5. This one is 0.95 grams. And there is our answer for number 7. Well, our last problem here, it looks as though we have 100 grams right there. And we have 60 grams back here. And it looks like this is almost on the 3.8, almost on it. Now again, there's a judgment call. You can call this 3.75 perhaps, or you can call it 3.80. I'm going to go with 3.80 grams. It just looks very close to that 3.8 mark. Closer there than it is to halfway between the 3.7 and the 3.8. So I'm going to say 3.80 grams. So 163.80 grams, 163.80 grams, and that is our measurement right there. And those are 8 problems. Hopefully you understand now how to use this triple beam balance to find the mass of an object. And remember, the same rule applies here as applies when you're measuring with a ruler. The last digit is an estimated position, and it can be either a 0 or a 5. It can't be anything else. But when you measure mass with a triple beam balance that is precise to a tenth of a gram, you can have one digit in the hundredths place, an estimated digit, and that digit is either a 0 or a 5, and that place, the hundredths place, that's where the error is.